Uncharacteristically tight timing.
Yeah.
Worries me.
Uh-oh.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 314. Ooh, it's Pi, but also PCBs in living color and ultrasonic everything. This week in Hackaday news is no news is good news. We couldn't find anything particularly.
It's a boring world. What can I say? There's absolutely nothing going on out there.
Oh, no comment, but no good Hackaday news this week, y'all. So yeah,
Get busy.
Get busy, exactly. But that does leave room for what's that sound?
Oh, goody.
This is a journey into sound.
What's that sound?
This week is a pick the winner week. Last week we played a brand new sound. You all wrote in. A whole bunch of people wrote in. Jenny speared it.
Uh-oh.
Jenny was on deck last week. She absolutely 100% knew the sound. So much so that I had to bleep out like half of her commentary afterwards.
All right, let's see what I can do with it. Initially, I'm thinking router, but it sounds more like a surface planer.
Oh my God. What?
Did I get it wrong?
You did.
I got it wrong.
Listen
on.
again. Listen again.
It's not cutting wood. It sounds like it's cutting metal.
It's definitely cutting metal.
All right, yeah, I'll just go back with the CNC router then.
Oh, what do you cut metal with? I mean, everything is the answer.
Yeah, whatever surrounds.
Hacksaw.
Sometimes I just bend it until it breaks.
Angle grinder.
Really?
That sound was so angle grinder to me. I'm sorry.
I don't know. I feel like I'm hearing multiple cutting edges in there instead of grinding, but okay, I'll buy it.
I think you're hearing someone who's, kind of wiggling back and forth across a piece of God knows what, angle iron or something.
Wow. Okay.
I don't know. I mean, it's grinding. You got the grinding right. You got the cutting metal right. Just the implement was not quite.
Wow. I got to get to the shop. I'm spending too much time writing.
I think so. Jenny was like, I grew up in a blacksmith shop. Jenny's father was a blacksmith. She's like, there's no sound I know better than the sound of an angle grinder. And I'm like, yeah, that's probably right. What do we get? 109 answers, of which 76 said angle grinder. So pretty solid, everybody. Pretty solid. That's a 76-sided die is tricky. We'll have to resort to fake random numbers. 2 or 3 people left comments saying, absolutely an angle grinder. I can even smell the cutoff wheel. And I'm like, yeah, exactly. I get exactly that. Somebody said it was burning metal. I don't know if it's the burning metal or if it's the...
I think it's the epoxy.
Yeah?
Or whatever the matrix is that makes up the disc. Now I'm thinking that's probably, good to look into. What are cutting wheels made out of, and why do they smell that way?
Yeah, exactly. Well, they smell a little bit like brake discs, which makes me worry that there's asbestos in there or something.
Wow.
But maybe it's just the binder. Maybe it's just the binder.
Yeah.
Oh, now inquiring minds want to know.
Yeah, I'll write it up.
The most popular wrong answer was by far table saw and circular saw. You got the rotation right, but the blades versus grinder wrong. There were a few that said other kinds of grinders, bench grinder, for instance. I thought this one was so distinctly angle grindery. I don't know. I can almost even hear that like janky gearbox that's in the right angle drive thing, I think. At least in my mind.
Maybe I got it wrong because I'm always wearing hearing protection when I'm using a grinder. That's it.
That's a brilliant excuse, and also a number of people wrote that in the comments. They're like, "Where's my PPE?" Here, the people who didn't get the smell of the angle grinder like I did were all like, "Where did I put my earplugs?" And my, but for me, it's glasses. I really don't want to get pieces of metal stuck into my eyeballs.
Oh God, no! It's not the metal that I'm worried about. It's when the disc breaks. Tomahawks across the few feet between your hands and your eyes, and I've seen some horrible injuries like that, and then some pictures of people who've had like a full face shield on, and they've got half of a disc sticking through the plastic and pointing right at their eyeball, and it stopped just short. Just horrifying.
I was told by a guy working at a shop actually fairly late in my life that those cutoff wheels have an expiration date on them. And you should actually check to see how long they're good for and not use them afterwards because they get more brittle as they get older. And
I could see that.
Yeah, so those discs that have been sitting on your shelf for 10 years right now, do not use them. Buy new ones. It's not worth it. They're like $1 each. Buy new ones. But yeah, use your goggles, use that cutoff shield, but enjoy the sparks because it's so fun.
Yeah.
Let's see. Okay, so I have to figure out a way to roll a 76-sided die. I don't think I've done the NIST one in a while. I'm going to use the NIST random number generator. So 76. Downloading a random number from National Institute of Standards and Technology. Random number is 69. Nice. And congratulations to Irish Boss. The correct answer, of course, is angle grinder. The number of people who put just straight up angle grinder, no comment, no nothing, is actually also astounding in this one. There seems to be some debate whether you capitalize the A and the G or both or neither. I like the ones who call him, who is like first name, last name, angle grinder. I like that one.
Or in the Army, it'd be grinder, angle.
Yeah. Well, thank you all for your answers, correct and otherwise. We'll have another sound up next week for you all to guess at which for you all to guess. All right, well, let's head off to the hacks. If you were reading Hackaday this week, you'll notice we have started rolling out the SuperCon 2024 Design Lab talks in force. And we're going to keep doing that for the next week or two. I wanted to start off with the first one we released in this new batch. This is Alex Toussaint's Hackaday SuperCon talk, Killing Mosquitoes with Freaking Drones and Sonar. And this talk ends up not being about killing mosquitoes so much as a really awesome sonar device that he made. That's, I guess, what I want to talk about too. He started off, though, with a quadcopter, with a drone quadcopter application. And that is when he was a kid, he always wanted to be able to program a drone to go over to the fridge, get him a drink, and fly it over to him in his living room. It's an impossible project. It's a difficult path planning and navigation project to do that autonomously. And he hasn't actually succeeded in that yet. But what it did was it led him to look into ultrasonic rangefinders and how to use like 3 or 4 of those on a drone to keep it from colliding with walls. And then he took that to the next level and made a really nice beamforming version of this ultrasonic rangefinder array, which we actually wrote up back in 2021. The PCB has 96 of these kind of normal size ultrasonic emitters on it, and then just a rat's nest of wires coming off the back of it. And in the SuperCon talk, of course, he puts the slide up and half the audience is just laughing when they see it. And he's like, yeah, don't judge. But he got really great results with that. And like I said, we wrote it up on Hackaday back then. And the trick with beamforming arrays is that the distance between the different microphones kind of controls how tight an angle you can resolve. So if you want to know this thing is coming from over there, you have to have the microphones spaced close enough together so that you can point a tighter beam essentially at that direction. The limitation of these kind of, whatever they are, 1/2-inch diameter ultrasonic sensors was bothering him. So he ended up using, in this version, which he calls Le Sonar 2, Alex is French, is a TDK T3902 MEMS microphone. And this is a little bit of a hack because these are microphones meant for kind of normal acoustic frequencies, but they also, due to being MEMS and just hella tiny, receive just fine up into the ultrasonic. He needs to do some filtering and stuff on the resulting signal, but Alex doesn't seem to be at all scared of doing some DSP. The result here then is an ultrasonic microphone array with 380 of them in a kind of 5-inch by 5-inch square. And so they are packed in there tight, 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 and many, many. And that means that he can pinpoint reflections, ultrasonic sound reflections coming from the room from an extremely tight angular resolution. And then up at the top, of course, is an array of ultrasonic transmitters. So those ping out, sound bounces off of whatever, and the microphones listen back to it. Because they're doing beamforming, they can tell which direction the sound came from, and because they know the timing, they can figure out how far away everything is. And so what he ends up with is kind of a 3D view of things in the room. Now back to mosquitoes, this is where it gets crazy. This thing has resolution that it can tell where a mosquito is in the room at about 2 meters away, which is absolutely insane. And then the last bit is truly crazy. So he's also written some software for this thing so it can do not just the ultrasound, but it can tell how the ultrasound received has been Doppler shifted. And so using the Doppler signature coming off of the movement of the mosquito's wings, he can tell whether they're mosquitoes or flies or wasps, because wasps have bigger wings. And so they're moving slower at like the root of the wing and faster at the outside of the wing. And so the sound gets Doppler shifted over a wider range, the bigger the animal's wings are. And flies have stubbier wings and mosquitoes even shorter ones. And he can actually, using this weird, he calls it micro Doppler frequency shift, he could certainly discriminate mosquitoes from wasps and probably also mosquitoes from flies. And so he's got a sonar unit that can not only tell you where the mosquito is, but tell you that it's a mosquito and not a fly. Still on the to-do list, of course, is tie this thing to a drone and fly it around and beat the mosquitoes up in the propellers, or, figure out something else to do with this device. He suggests it's also super useful for finding leaks in things. Small pinholes tend to make ultrasonic sound. And so if you had an ultrasonic 3D sound camera like this, it would be super useful for people diagnosing leaks in systems. I don't even know what else it would be useful for. I think that this one application is probably just the tip of the iceberg.
A couple thoughts on this. Probably the title of this talk should have said something like, no mosquitoes were actually harmed in the making of this project, because the comment section brought out a lot of people who were seriously concerned about the mosquito genocide that this thing could unleash. And I get that. I don't like the idea of eradicating a species, even one that's been studied to the point where, it's pretty clear you could just get rid of mosquitoes and not a lot would change about the ecosystem. I don't know if I 100% trust that, but still, you can't deny the fact that mosquitoes, lol, suck. They're terrible to be around. They transmit disease. There are reasons for wanting to get rid of mosquitoes in an area. I don't know if you want to get rid of all of them, but whatever. But anyways, the trolls in the comment section did come out to point that out.
How did anyone get to eradicating all mosquitoes in the world? Like this project,
exactly.
This project is clearly a hacker project to B, fly a drone around a small area. Like, what kind of battery pack do they think is going to be on these drones that they're going to fly around the whole world and wipe out all mosquitoes? Like, where did this idea even come from?
Especially given my second point, which is we already have a system, an airborne system, an autonomous airborne system bearing ultrasound, detection equipment that is extremely specialized for killing mosquitoes, and it's called bats. And we have a metric crap ton of bats are out there trying their best to eradicate mosquitoes, and they still haven't come up with a way to do it. We still have mosquitoes, we still have bats, right? So even if we fielded as many drones as we had bats, and they were as efficient as bats are at taking out mosquitoes, even if we did that, even if we augmented our bat population with drones that were as efficient as they are at taking out mosquitoes, pretty sure we'd still have mosquitoes.
Hyper bats.
You're just saying, that's already out there. But.
Runner Pack's comment, I wonder if the system could be modified to detect trolls and chop off their keyboard cables.
I saw that comment. I did like that. That was good.
Beautiful. No, This is just such a great talk. You really should watch it because it's really neat on the issue of sonar, and it's really neat on the issue of beamforming, and there's even like a lightweight kind of DSP primer if you actually want to see how the math goes behind some of this. And then there's just some gonzo hacker engineering. These little MEMS microphones, they put out pulse density modulation signals, and that means tons of bits per second. And times 380 of them means that he has to use an FPGA to do the work here. And there's actually some filtering he has to do to get rid of the not ultra sound, the kind of normal sound part of the spectrum, so that it's just the ultrasound ping that's getting correlated with itself. Anyway, really, really cool project and an awesome talk to boot. Give it a look if you haven't yet. And if you haven't seen it this week on Hackaday, you haven't seen it because it just came out.
Okay, first up for me, unnecessary, in quotes, automation of a DIY star lamp build. And I think the scare quotes are well-deserved in this case because I feel like this is a project that couldn't exist without a level of automation, even though it's designed basically to build an N of one. It's not designed to build a whole bunch of these things. These things are very interesting looking concrete hemisphere decorative lamps with embedded fiber optics. It's kind of like a reverse planetarium. So instead of projecting light onto a dome that you look at the inside of, it's a dome that has fiber optic elements piercing it in various places and that lights up, and it's very decorative and very good looking. This one is from the channel Unnecessary Automation, ironically enough. He goes through this whole process of building a machine that's going to build these lamps. He does intimate at one point that he built one manually at some point and probably, had enough of that process right from the start. So much so that he spent weeks building this automation rig to build these things. Basically what the rig is a sort of a polar coordinate gantry. So it can do theta, azimuth, and altitude sort of coordinates that go around this mold. It looks like a clear acrylic sort of hemisphere, and drill holes in it. So he's got a number of different tools that can be moved around the surface of this hemisphere. And the hemisphere itself can move on its own axis. He's got a drill that can actually drill the holes. And then, since he wants to stick fiber optic pieces into each one of the holes, he basically came up with the same kind of approach as a 3D printer filament handling. It's got the extruder sort of mechanism that shoots the filament through the hole he just created and then needs to glue it in place. And kind of went through a whole bunch of different candidates for glues, different epoxies, hot glue, that kind of stuff. And the only thing that really ended up making sense was a UV cure adhesive that is dispensed at first with like a syringe pump, but that didn't work too well because the glue was actually hardening in the syringe. And then he came up with this peristaltic pump that can dispense just the right amount of glue through a tube into the hole, and then swings a UV LED onto the surface, cures the glue, and moves on to the next one. And then he's got this whole thing programmed to put these patterns in. Patterns are generally something related to the stars in the night sky, which is kind of cool. But I also saw one of his examples said subscribe. So I guess you could pretty much put whatever he wants into these patterns. And the whole thing just ends up being a mold for the concrete that he's going to pour in later. And it's like an epoxy concrete mix. Pours that in there, has to peel off the mold. And that's a tedious process. The whole thing ends up looking great once he's got the whole thing cleaned up and placed on a stand. The bundles of fiber optics go down to an 8x8 neopixel matrix. And then he can light up bundles of LEDs at specific times in different kinds of patterns. Very decorative, very beautiful. But I really feel like this was a project that you could almost not build, or at least not build very well, without going through the effort of putting some sort of automation into place. And it almost seems like overkill, but I'm convinced that this would have been the kind of project that I would take on and get about 3 holes into this and realize, I ain't doing this. It's just like, I don't want to build this project anymore. But building the automation would certainly keep me engaged and entertained enough so that the finished product almost, to me, would be like, okay, well, whatever, but look at the cool robot I built. And I think that's kind of where he is with this.
I absolutely agree. I think that's part of the story. I think he made one of these because he wanted to, and then he's like, "Oh, I could try to make a machine to do that." And like that gives you the excuse to make more of them, but it really gives you the excuse to make that crazy machine. And it's just so fun to watch it go. It does these individual steps, one after another, and then it rotates and it's like drill, insert fiber optic, come in with the glue, come in with the cure. And like all of them are on little servos that move around and put them into the right place. It's like a little factory, but it's sitting there on his desk. And I really think that's fun. There are tons of silly little details, like you mentioned the glue and the feeder, but there's also there's something needed a little bit of a spring on it, and he uses like a razor blade as a spring that flexes only in one axis, but it won't flex in the other because it's a nice flat piece of spring steel, basically. There's a bunch of cool things going on here. Absolutely worth watching. But for me, anyway, the machine is more fun than the lamp, and I really like the lamp. But the machine, I think that's where it's at.
I just realized that there's like 1,000 fiber optic penetrations in this thing, and that got me to remember that back when I did laboratory automation, that was one of the things I used to justify whether a project was worth automating or not. And, it's like management and stuff like that. My line was, if you have to do 1,000 of anything, you need to automate it. Yeah. So, I'll take that. It was sort of a throwaway line, but in this case, I think it does make sense to have gone through the effort. And you could do the XKCD thing where it's, the chart of the amount of time it takes to automate something versus the amount of time it saves per unit time. And I don't know that necessarily applies here, but that's certainly a relevant XKCD. So we'll throw that one in the show notes.
Like if you wanted the stars to be accurate in this, there's no way I could do that for more than like 100 stars because you have to mark them all out on a sphere. I don't think so. Machine necessary.
Machine all day.
All right. Well, if it isn't abundantly clear, I'm stoked to be getting the SuperCon Design Lab talks out. And my next hack is a Joe Long talk from SuperCon 2024, A New World of Full Color PCBs. And Joe is, in addition to sometimes writing for Hackaday, he runs a company called HackerBox, and they make fun kits. And that means making cool PCBs for people to solder together. And he's been in the badge scene for a long time now. And this year started experimenting around with the brand new possibilities of getting full color silkscreens done on your PCBs. And that's largely what this talk is about, is his experience doing this kind of a big hacker scale. More PCBs than I've ever made in one run, but not, like Samsung or something. I guess he starts off talking about, the old state of play in badge art, which is kind of the 4 or 6 color palette you can get from leaving on solder mask and taking off solder mask, and having copper on one side, copper on the other side, no copper at all, just the color of the PCB. He goes through the different palettes you get out of that very nicely, actually. It's a really great talk for that before he dives into this full color silkscreen madness. Basically, the story there is that the two big Chinese board houses, JLC PCB and PCBWay, both in March of last year, started offering full-color silkscreen. Full-color silkscreen is basically just a full-color inkjet printer, but it runs a UV curing enamel ink, like the stuff that normal silkscreen is made out of. And in fact, they've all been using these machines to kind of inkjet print out silkscreens. It's been a long time since the silkscreen layer was actually made with a silkscreen. Instead, they're just doing it in white. And then once they had machines that could do full color on top of this, the question was, why don't we offer that as a service? And so they have. They both did it at about the same time, and they both have kind of different flows to get the job done. If you think about the usual PCB manufacturing flow, you design the thing, you get a silkscreen layer, and you ship that all off. They take the silkscreen layer and they pull out their white ink and they put it on there. But what if you want that to be multiple colors? the two different approaches here, PCB way just takes basically a picture from you and uses that as the silkscreen layer. This is kind of the easiest way to go in a way. Like, you make your board the normal way, you take a picture that fits over the top of this board, and then you make cutouts for whatever components where you don't want the silkscreen to be. That is, on the one hand, conceptually very easy, but on the other hand, you are responsible for unblocking the parts that don't need to have silkscreen on them. In the end, it's just your regular PCB design flow plus an art flow over the top of it. JLC PCB, on the other hand, they have this easy EDA design software that they make you use. I haven't used it. A lot of people have. Basically, everyone I've talked to who's used it says it's just fine and you should get over it. Joe says the same thing, actually. He's like, I didn't want to use this not free and open software. And the funniest thing, a couple times in the talk, he's like, so you can edit this image using GIMP or whatever that Adobe pay to play version of GIMP is. and then he's like, he's talking about the old school badge design. He's like, you could do this in Inkscape or Adobe's Inkscape clone. And I'm like, yeah, that's right. So Joe's kind of a free and open software nut and uses KiCad, of course, to do his PCB design, but bit the bullet, took one for the team, learned how to use Easy EDA. He says it's just fine. And the nice thing about JLC's flow is that you can bring that full color image into their Easy EDA, and it basically cuts out the parts where you need to solder and the parts where the components are and all that for you. So with PCBWay, you can do the image however you want it and just zip it into the bundle and send it off to them. JLC, you have to use Easy EDA, but because of that, you can then just import the image into Easy EDA, and it does a lot of the fiddly work in making the silkscreen work with the board for you. Which of those is easier? Beats me. He says it's basically a wash. You could do it either way just fine. See which one works better with your workflow. Why would you want this? And aside from, crazy hackers making cool looking badges, I don't know, but Joe has a couple really interesting ideas here. And one is that he makes kits for people and they have to solder components on. And so instead of just a silkscreen where you have like a white outline of the part, he's actually got a full color picture of the part. And so if you look at the board before it's populated, it's got a battery holder on it and it's got a picture of batteries on it. Like, it's completely unambiguous where you need to put that battery holder on the board. You just make it look like the picture. Similarly, it's got like a microcontroller module on it or something, and it's just got the picture of the castellated microcontroller module there. It's really, really neat, and I think that's a cool idea. One of the things JLC suggests you could do with this is like make the outlines around all your capacitors red and all your resistors green. And this will help people in assembling component kits if they're doing it. They take it one step and Joe takes it like 17 steps further. But, hacker mentality. He's a clever guy. It's a neat new option that's available to us all at the moment.
I mean, when I first looked at this, I was like, well, what's the point? Then I saw the badges, and I was like, oh, yeah, that's the point. SAOs and badges would certainly be a great application for this. There's also a whole bunch of people who are using PCBs not to create circuits, but to create, other things, like using them to make enclosures and control panels and stuff like that. Super useful for that, I would think. And I don't know, I'll take issue with the photorealistic parts placement. I think is actually a little bit of a problem. It's kind of like, those tool organization systems, I forget what it's called, where it's instantly obvious if you've left the tool like in an airplane, because they've got an outline of the tool, and then you can see that the tool is missing because the background color of this organization system is showing through. It seems like it would not be immediately apparent that you've missed placing a component if there's a picture of a component on it. Yeah, it's 2-dimensional, not 3-dimensional, et cetera, et cetera. I'm sure it would show up eventually, but I just feel like it would be confusing, even though it is really cool and the results are gorgeous. The boards look great. And I think there's other better applications for it is all.
I like the idea that you're actually fooled so much by the picture of the like batteries in the battery holder that you forget to put the battery holder on there. He has a slide in his slide deck where he has it before population and after population, and you're right, it's not as obvious that the batteries are missing. Although I think if you have this in real 3D space in front of you, it's going to be
It'd be
partly
more obvious,
obvious.
obviously.
But maybe with the small things, like you're saying, maybe with the small things, it wouldn't be so obvious. And I think that's pretty funny.
In a kit situation, you're probably not putting, 0106 components in the kit for people to put on the board. So there's going to be more detail in the, like, if you'll be able to tell if a diode needs to go this way or that way based on the printed footprint. It's really cool. I'm glad it's available, and they look pretty stunning. And it's also kind of cool that it was just sort of a, hey, we could do this out of the board houses when they realized, there's nothing stopping them from doing this, and they just offer it as a service now. I think that's kind of cool and speaks to where the industry has gone.
Well, I tell you what, on that topic, the first time I ever saw full color PCBs was back in 2018. There was a company in Shenzhen called MakerNet that did, small scale PCB stuff, and they offered this as a service way, way, way back then. And actually, we got some badges made. Brian Benchoff, of all people, got these full color Tindy badges made, and some of them he was doing himself with pad printing, but one of them he got done by MakerNet, and it is absolutely stunning. I'll throw a link to that in the show notes for you so you can read up on that. But again, it didn't become mainstream until, the big board houses came on board. So, you're right. It's kudos to them for stepping up and doing it. Part of me, though, feels like I'm going to miss the old school, clever work that's involved in getting something to render in 4 colors or 6 colors. And in particular, in the palette you've got on whatever PCB that is. And I'll call it now. I think there's going to be a rift in the art badge community between the people who think that just getting a full color print on the top of your thing is totally cheating, and those who think it's a really neat opportunity. I can definitely see it both ways, actually. If you want to see some of the kind of more classical badge art stuff, Twinkle Twinkie gave a great talk at SuperCon 5 years ago now. The Way of the PCB Artist, How to Make Truly Beautiful Circuit Boards. I'll throw that one in there. There is a certain aesthetic to the, what can you do with 4 colors? It's like the, if you're not doing posterization, is it making PCB art? And I don't know what the answer is here. I've seen really kind of objectively beautiful things done with PCBs using the super limited color palette. And I really like some of the things Joe's doing with his. So, yeah. Jury's out. This is kind of going to be a split in the PCB art world between the photorealistic and the kind of more expressionistic PCB art. And so these UV curing photo printers are really neat. And right now you could buy them for large commercial applications right now, but it is probably only a matter of time before one of the Chinese small device manufacturers, maybe 3D printer company or something, comes up with a way to miniaturize one of these and make it usable for the home gamer. I've actually got some information that I think would be breaking an embargo if I told you about, but I think that there will be these machines coming out on the hobbyist space probably this summer or so. Unfortunately, for kind of a $2,000, $3,000 price tag. So it's going to be expensive, but I don't think this is going to remain expensive forever either, because it is just inkjet printing with a slightly thick ink and then curing it with a UV light source afterwards. So I don't think it's going to remain out of reach forever. And what people will start doing when they have these machines, in their hackerspace or whatever, is going to be very interesting.
Okay, my next pick is Integrated BMS makes battery packs easy. This is going to hit at the battery building community, which is pretty substantial. There's a lot of different ways to build lithium battery packs. I mean, you could just short circuit that altogether and just buy a pre-built battery pack. A lot of times you need a custom size, a custom capacity, custom physical footprint. Something about it needs to be custom built, or you just like building things. And you end up a lot of times taking the battery management system, the BMS, and slapping that on the side of a couple of cells and wiring it up to the individual cells so that you can monitor the voltage on each of the cells and charge them independently. And there's nothing wrong with that. That's certainly, time tested. I've got 2 battery packs sitting in my solar setup right now that both have off-the-shelf BMSs wired into a 14S 2P, I think it is, pack. It was a pain to do. This aims to sort of get rid of all of that flying wires and double-sided foam tape and other kind of janky things that you might put into a BMS battery project. This is by Call Me C, and it is a BMS on a PC board that fits on top of 4 prismatic lithium iron phosphate cells and screws directly to them. Generally what you see is that the batteries are put together with either nickel or heavy copper bus bars between them. This BMS builds the bus bars directly into the PCB. I think, I'm not 100% sure, and I haven't opened up the Gerbers to see exactly how this is done. I don't know if there's pore layer of copper in the tabs that connect the terminals for 2 different cells. So I'm not 100% sure of what's going on in there, but still the PCB itself is acting like the bus bar, and all of the BMS capability is built right into this PCB, which sits on top of the battery pack. So you get this nice compact monolithic construction that looks like it's a lot more robust than your general, wrap it in shrink wrap tape and make sure the wires don't go flying all over the place construction that I've seen with a lot of DIY battery packs. There is some concern that, that there's physical movement of the battery, very little bit of physical movement of the battery. It does swell and shrink slightly as it's charged, and that this movement might result in some sort of physical, mechanical damage to the PCB because you haven't built in any sort of physical strain relief. You'll see on bus bars that are used to connect prismatic cells like this, often you'll see like a little kink in the bus bar. So it's got a little bit of a spring area in the middle of it so that the bus bar could contract and expand slightly. I don't see that here, and I don't know if that's a problem for in this particular case. As far as capacity goes, Call Me C said that they used it to jumpstart a car. It's rated for 200 amps, and it was able to jumpstart a car. So obviously the bus bars inside the PCB are doing the job. Whether they'll do them for a long time or not is, I suppose, open to debate, but still, I think it's a really cool design, and I like the way that it just sort of makes the whole battery one physical entity that doesn't have everything flying all over the place.
Agreed. BMSs are like the heart and soul of lithium-ion batteries pack. I've swapped BMSs on hoverboard batteries, and it's a lot of soldering, and it's a lot of soldering with a live battery, and it's a little bit sketchy. You don't want to like touch the wires together. You got to be sure about what's grounded and what's not. This one, it just screws on. Like you could imagine it does fail for whatever reason. You can actually just unscrew it, pull it right off the battery pack, put a new one in, and you're good to go. So I think that's actually a really cool, the kind of modularity of the BMS unit here is also a cool advantage. And you don't have to worry about the connectors that connect to the BMS because those have to be beefy enough to carry the rated current. Here, as long as that board is thick enough and the copper on traces on it are thick enough, you should be good to go. I'm not a battery expert.
Yeah, I mean, that's one of the things that always kind of creep me out about working with batteries is that especially big ones, like this, it's a little different with an 18650 or something like that, even though those are a little bit scary sometimes. They get a little spicy. A big prismatic cell like this or some of the big flat packs that I've got like in that battery pack I mentioned before, there's nothing you can do about about making them safe in terms of, if you make a wrong move with a tool or you have a wire that's flipping around too much, that's it. It's done. You can't, it's going to blow up. It's going to short the cell. It's going to vaporize whatever tool you happen to be, handling, overheat, a whole bunch of things. And there is absolutely nothing you can do about it, because at some point, you've just got to have a conductive terminal sticking out of it, and charge is there. It's all stored up in that battery. There's no circuit breaker before that, or, no way to turn off the chemistry in the cell.
The gun is always loaded.
Its gun is always loaded. You have to be careful. And I've had the experience of, I think I'm wiring up a BMS, and a terminal, a wire with a terminal on it got loose, and zoop, and it, of course, just decided to spring exactly in the one place that it shouldn't go, and bam, this thing lights up, and what are you gonna do? There's nothing.
Sparks. Bringing up the rear for me, Nick Ivanov's project Mural, the plotter that draws on walls. And this is a sweet take on a project we've seen a bunch of times. You basically have two motors that pull on wires, and they move a kind of a gondola around, and it has a pen on it that can plot on your wall. And I don't know what we call these things, but we've seen them since forever. And actually, before I was Hagaday's Elliot, Elliot Phillips was Hagaday's Elliot. And he comes in and mentions Hector, which was a wall-mounted spray paint bot done by Jörg Lehny and Uli Franke in 2002. As far as Elliot and I know, this is the first time we've ever seen this kind of bot. But we've seen a bazillion of them since then, because it's just so appealing. This project is a really nice one. It uses 3D printed frame and a bunch of modules. You can mount the stepper motors in there easily. The whole thing is very much self-contained. The motors are inside the drawing part itself, and so you just connect two timing belts somewhere on your wall, and it moves itself up and down. There's kind of another version of this where you put the motors on the wall, and the thing in the gondola is more minimal. And like, I'm thinking of Trammell Hudson's Polar Graph. More links in the show notes on this one, which was actually, in one of the original versions, was just a stepper motor and a dry erase pen as the sled, and then it was held together by wires. And at some point, people making this style machine, where the wheels that turn it are mounted on the wall with the motors, noticed that you have kind of a variable point of contact with the wheels when you do this, and then started adding screw eyes to it to kind of regularize the geometry. At around about the same time, the people who were putting the motors in the gondola also had that same realization, and a bunch of people pointed this out in the comments, pointing to Stringent or Stringent, the wall plotter bot, where the realization was that if you crossed the wires, instead of having the left one go off to the left and the right motor go off to the right, you cross the belts over, it gives you a nice triangle automatically. Problem with Stringent, though, is that it wobbles a little bit. And this is a common problem with all of these wall plotter bots, is that if you try to move them too fast, the gondola itself either cants over to one side, or worse, it actually swings back and forth. And so there's kind of a maximum speed you can go to with these, unless you are very careful to pull down on the thing and, give it a third force. So gravity alone may not be just enough. You might want to add your own. And we've seen a couple working in this mode. One that I really love isn't exactly a wall bot. It's actually a 3D plotter winch bot done by Homo Faciens, where he has 3 wires holding the thing, and then a bar that points down on the top and pushes it down, kind of augmenting gravity and preventing it from wobbling. Same kind of idea. One more, if you're interested in designing these, you should think about. This one is a pen plotter, is about as simple as it can get. It is, again, driven by these 2 wires, but it's got another pair that come off the bottom, so it makes kind of an X with the control wires. But the 2 on the bottom have a rubber band in the middle of them, so there's a little elasticity there, and they're just kind of free floating to keep the thing stable. I think that's a really cool idea. What I'm surprised is that I've never seen a legit 4-motor wall plotting bot. It's an overdetermined problem, right? Like 2 wires is sufficient to define the plane, and a third kind of is overdetermined. 4 would be even more so. But I'm surprised that I haven't seen anyone work out the kinematics to make such a bot work, because it would be dead stable on the wall. You could probably run it a lot faster, and I hope I've planted this idea in your head.
The idea that the wall was probably not perfectly plumb was sort of my worry point on this. Like, I could easily see, if this had a pen that, had to go down, like you have a servo-driven pen to contact the wall. If you had just the right sort of conditions, I could see that bouncing the whole print head, quote unquote, away from the wall instead of printing. And I've seen walls, I've built walls terribly out of plumb before, so I know that's a real risk. I could also see this, being deployed on, in a big outdoor sort of a guerrilla art sort of thing, where you've got a big wall, you tack the 2 supports up to the, the parapet of the wall, and then just set this thing going, and then muralize that entire wall. Probably need something different to put the marks down, maybe spray paint or something like that. That would actually be really cool, wouldn't it? See something like this just, being basically a huge inkjet printer on the side of a building. Now I'm giving people ideas that maybe they shouldn't have. But anyways, wasn't there a CNC router that...
Maslow.
That's it. But they solved that problem by sort of slightly tilting the bed, or what, I guess the wall in this case.
Right.
They had that kind of tilted back a little bit, so you get that sort of vector, the gravity vector working in your favor. But yeah, that was the kind of the first thing I thought of when I saw this.
Yeah, I love that this idea has been kind of re-implemented so many times. I'll have to drop a link into Nicholas Roy's talk. He actually just gave a talk at Hackaday Europe about a wall painting graffiti bot that he made, and 3 different versions of it. It's a marvelous talk. I'll throw the links in the show notes. We haven't written it up yet, but the video is up on YouTube. You can find it. If you haven't made one of these yourself, you absolutely should. I think this mural is a great example of a very modern take on this. Like, he uses the really nice Fluid NC G-code controller. Just does a lot of things right. The other thing that's really fun about it is that he uses washable marker, and so he just is like literally just drawing on the walls inside his house, which I think is hilarious. I think you can just wipe it off with water later on. A lot of freedom there. But if you want to start experimenting with these, I think you absolutely should. You'll run into the trapezoid problem or its other friends. You'll run into the acceleration and the wiggle problem. I think you could solve a lot of this brainstorming now. I think you could solve a lot of this with computer vision. If you put like an LED on the thing, you could map out, just kind of brute force all of the coordinate positions to how many steps they are away from their center. And you could actually make it really, really, really square without having to do any of the math involved. Or I think you can do what a lot of people who've built these machines have done, and that includes me actually, which is just live with the fact that what you think should be a straight line has a little bit of a curve to it. And just draw something organic instead. Don't draw straight lines. Just work around the problem. Draw pictures of people, draw cool logos. It's not going to be so distorted that you have to worry about it. And actually, if the attachment points are far enough away from where the drawing takes place, all that kind of just washes out anyway. So you don't have to worry about your lines curved as long as they're far away from the attachment points. So I don't know. In principle, this is such an easy bot to build that it's one of those that everybody should do at least once. And worry about the refinements later.
All right, my last pick for today is cheap endoscopic camera helps automate pressure advance calibration. And this comes to us from Marius Wackler, who was having a hard time getting his 3D printer sort of dialed in on all of the settings, and really wanted to take his printing to to the nth level. And so was working out these somewhat obscure parameters like pressure advance. Pressure advance really is basically just accounting for the elastic tendency of the melted column of plastic that's in the extruder to kind of spring back and forth. So you apply some pressure with the extruder and it oozes out, but you stop the pressure and then it continues to ooze pressure advance will help you avoid the continued ooze. Basically, it's a factor that needs to be determined experimentally, and there are ways to do that. You can print a test pattern, and then sort of look for the best one, and then use the pressure advance setting that corresponds to the test pattern success. But that's so old school. We don't want to do that. We want to do it automatically. What Marius did was to take one of these cheap cameras that you can get on eBay. I called it an endoscopic camera when I wrote this up. I realized that's probably not the right term for it. You don't really want to be sticking these cameras in any part of your body. More like a borescope. Let's call it a borescope camera. But anyways, you know what it is. It's like the tiny little cameras that are on the end of a long USB cable. You hook it up to a phone, put an app that's probably stealing all your information on the phone, and then you look and see what's going on. You can stick this camera in a hole, in a wall, find some wires, that kind of thing. They're actually very useful, and they're cheap, and they're good to have around. Marius stuck this camera on the end of his 3D printer where he can get a good look at the test pattern that's printed. And the test pattern is kind of like a ladder where the individual horizontal rungs are printed at different pressure advance settings. When you look at it, you can obviously see that some are printed better than others. And that's the job of the camera, is to image that and then do an analysis of exactly which one printed best. That actual process is sort of the secret sauce of this one, I think, because you take away the background, which is the bed. You have to account for the lighting. You have to have the camera far enough away from this so there's no distortion, because the lenses on these cameras tend to be a little bit distorting. There's a whole bunch of stuff that has to go into that, plus then you've got to measure the thickness of each one of those lines over the entire length that it was printed, so that you can kind of see which one was the best, most evenly printed line. And once you've found that one, you take the pressure advance setting that was used to print that particular line, and then use that for the rest of the operations. The results are pretty good. He does show some before and after prints, plus minus prints with pressure advance properly set. And you can definitely see in the layers, you can definitely see a blub that sort of forms consistently when the print head changes from one layer to another, because that extra glob of material is coming out. With the pressure advance setting correctly calibrated, that blub largely goes away. We've seen this before, this whole kind of concept before, but using, I think it was a laser scanner, basically measured the width of each one of those lines. This seems to be a little bit simpler, at least as in terms of the hardware that you have to deploy to the printer. Cheaper and faster than using some sort of laser line scanner like we've seen before.
I was wondering if the difference in pressure advance settings changed from filament to filament, or if this was related to the printer geometry and speed. And some people have come back in the comments and said, yeah, it probably needs recalibrating every time you swap filaments. And in that case, doing something automated like this really makes a lot of sense, because you swap out a PLA for a PETG. They have different pressure response curves, and so you need to redo the calibration. Doing it manually sucks, so this thing does it for you. I think that's really tremendously useful. My 3D prints aren't good enough that I need to worry about pressure advance yet. And my firmware is not, fancy enough to do it. But when I get to the point that I'm running a super fast clipper machine, I'll worry about it. My first quick hack comes from Johannes. Chase Light SAO shouldn't have used 555 and didn't. This was an SAO project brought to Haggaday Europe. It has that Chase Light marquee effect all around the outside of it. It's done entirely mechanically with kind of eccentric cams and walking overlapping teeth. I saw it in person. It's absolutely flabbergasting. The videos do it justice, however, so you should give them a look. Next up, Simranjit Singh turning a kombucha bottle into a plasma tube. The plasma tube basically has electrodes at either end and a pretty decent vacuum in the middle. How you make a vacuum in a piece of junk bottle you have is basically the subject of this video. He has a couple really neat techniques here, including chilling the bottle and then hitting it with Nichrome wire to make a nice clean cut. He's drilling holes in the bottle using a glass drill bit underwater. I've never been brave enough to do that. And finally, he's got a nice silicone mold that he uses to make a lip around the bottom that then makes a custom gasket to seal it. He throws the whole thing in an even bigger vacuum chamber, draws a vacuum on it, and then that vacuum holds the plasma tube together, and he just has to put some high voltage on it, and he gets marvelous purple lightning inside. SJM 4306, LED filaments become attractive timepiece. Why haven't we seen more projects using those crazy little LED, quote, filament COB strips that are so cheap and so fun right now? I don't know. Here he's using them as lines on a clock and lighting them up. Project's not working yet, but it will, and it's a great inspiration. And last up, news from PCB Way. I guess we were talking about their full color silkscreen. They now have also added glow in the dark silkscreen to the mix. So if you need glow in the dark silk on your PCB for whatever reason, you can. You were talking about doing faceplates in the full color. How cool would it be to do them in glow in the dark and then have like little UV or blue LEDs that charge them up and let them glow?
That's pretty cool.
It'd be trippy at night.
PCBs, is there anything they can't do now? My first quick pick is aluminum business cards make viable PCB stencils. This is by Mikey Sklar, and it's sort of a follow-up to a project that we featured where he uses a combination of CNC router and a fiber laser cutter to make his PCBs. Making the PCB stencils, he also did that in that project, but he found out that cheap aluminum business card blanks are available at Amazon, because of course they are, and they make perfect stock for making PCB stencils. They're only 0.18 millimeters thick, not 0.8 millimeters like it originally said in the article, which is a pretty chunky stencil. They make great blanks for the fiber laser cutter and cut out the stencil patterns and then go on to make his PCBs. Next up, booting a desktop PDP-11. The reason I focused in on this one is because I remember these computers. I specifically remember the really cool floppy disk drives, the 5.25-inch floppy disk drives with the little flappy doors that faced each other. I remember these from when I was working in the computer lab way, way back, probably 1983, 1984, something like that. I had no idea those were PDP-11 machines at the time. They were in a part of the lab that I was not supposed to be frequenting, and yet I did anyways. And kind of played around with them a little bit and recognized the fact that they were kind of special, kind of weird. This was really before the PC revolution came about, so I wasn't terribly sure what was going on at the time, but this machine was actually really, really cool. And the look inside, all of the vintage chips and everything is really taking me down memory lane. And last up for me, 3D printed scanner automates deck management for trading card games. This is by Franz, and it's another one of his awesome automation projects. This one will take your cards for things like Magic the Gathering or Yu-Gi-Oh! Or whatever you do with trading card games and put them all in a hopper, feed them out one at a time, take an image of them, and inventory your cards. There's a lot of really fussy little details, as there always is with paper management projects, which is kind of what the automation end of this boils down to. Getting a single card off of the bottom of a deck is not necessarily a trivial problem, but Franz manages to get it to work, and then interfacing it to an app to actually categorize the cards was also a fun little project. Check out the whole thing. It's really cool, and it's got his kind of characteristic style that I like.
That cell phone interface is my favorite part. The app, once it recognizes the card, it goes beep, and so he built a little microphone that listens for the beep and then advances the machine to the next card.
No mods needed.
No USB, no problem. Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to feature Maya Pasha's So What Is a Supercomputer Anyway? And I think this is really fun because it gives her an excuse to go through the history of supercomputers and what made them super. I think jumping to the punchline, quote, Perhaps a fair way to classify supercomputers is that supercomputer aspect is highly time-limited property. That is to say, yesterday's supercomputer is tomorrow's pocket calculator. And Jeff White comes in the commentary and says, a supercomputer is a computer designed and built without regard to cost and with the target of maximum performance. I think that's pretty much sums it up too. And so that's kind of the story that Maya tells, is how it goes from the early electromechanical machines, which weren't really thought of as being supercomputers yet, to the kind of today's supercomputers, which are these just fantastically massively parallel machines where, they take up even more space than the old ENIAC used to. But there was a time in the middle, which I think is interesting as well, kind of 60s, 70s, when Fortran was king and doing as many vectorized operations at a time as you could was the big deal. And so these were kind of single/small number of processor machines that were just trying to do as many calculations as fast as they could on, simultaneously on long strings of data, but with one CPU. And this was, I think, the end of this era, and its high point is probably the Cray machines. And she brings up Seymour Cray's famous quote that using many parallel machines instead of a single large one is akin to, quote, plowing a field with 1,024 chickens instead of 2 oxen. And yet, the world we find ourselves in is a world where, one of the biggest supercomputers around, El Capitan, has 43,808 CPUs and is paired up with that many accelerator units. So, and these have GPUs and memory on board in them. And so this is like 11,000 of these essentially 4 mega computer nodes all wired together. And that's kind of the state of the art of supercomputers now, is that it's not so much Cray's one processor running as fast as it can is spinning in its grave. It's all about the interconnects now and how you divvy up the problems so that they run well over these massively parallel systems. To go back to Jeff's contention, which is the supercomputer is the most expensive computer you can buy, he follows up with, nowadays, supercomputers are built as massively parallel machines, which can scale pretty much as wide as you want or are willing to pay. And I think that's a good summary for the state of the art now. Now it's just like, you want a machine with 40,000 cores? Oh, you want a machine with 80,000 cores. There is a technological difference between these types of machines. It's not as much a technological problem as just the kind of funding problem. How would you build the building big enough for these? How would you get them all in the same place? And then how do you get enough money to afford all that?
I think there's a working definition here that everybody's sort of dancing around. Effectively, it's the fastest computer at that time, and that sort of calls back to it's a temporal sort of thing. It's gonna change over time. A more visceral sort of definition for me is it needs to be round and you need to be able to sit on it. So it needs
that's the Cray model.
It needs to be a Cray. I mean, I'm only kind of half joking about that because really that was the first time I ever heard the term supercomputer was in reference to Seymour Cray, and it's probably the Cray 1, which I saw one in person. It was at a computer museum, and if I remember correctly, it was like orange Formica, just gorgeous, really 1970s looking colors. And I remember reading an article about it and being amazed that, on the inside where you could actually step into the core of the computer and you could see the wiring, all those wires were cut to specific lengths so the the signals were timed to get there. And for 12-year-old me, I just thought that was incredible that you could build a machine that required that level of precision in the wiring. I also thought it was really cool that all the wires were the same color. That's a real power move right there. It's like, now we don't color code anything.
Cut the red wire.
We know where they all go. For years, that's sort of what I associated with supercomputers, that sort of circular format and Cray as a name. I know it's gone far beyond that in the modern times, but still, that's kind of my first interfacing with the supercomputer concept was about that, and that kind of stuck with me.
I love all the different varieties we get off of this. As computers became smaller and more affordable and moved into kind of offices, there were budget-sized supercomputers and mini supercomputers and super mini computers, which are apparently not to be confused with each other. And mini computers, which at the time were like that PDP-11 you were talking about, which doesn't look mini to any of us modern people, but, because it could fit inside a room comfortably, it was a mini computer back in the day. Maya closes by mentioning some terms that aren't as time sensitive as supercomputer, which is a mainframe. And a mainframe, she says, is a computer that's designed for bulk data processing that has as much built-in reliability and redundancy as the price tag allows for. And so these are the zero downtime computers that do all the financial transactions and et cetera. And I think that's an interesting kind of tangent on the supercomputer angle. If a supercomputer is the one that's built to run as fast as it possibly can and get as much science done per second, no matter how much it costs, these kind of ultra high reliability mainframes are kind of the opposite. There does whatever it does at whatever speed it does, but it does not screw up and it does not go down. And I think that's another interesting idea. And so it's kind of like that good, fast, cheap triangle, except it's like reliable, fast, and nobody's worried about cheap in either of these markets. They're all just hell expensive.
My can't miss pick this week is high frequency food, better cutting with ultrasonics. This is by Lou and Day, and this, touches a particular button for me that always manages to get my interest, which is automation of anything that has to do with food. I just find it absolutely amazing that natural products, like non-engineered products, let's say, cake or eggs or whatever the food product is, and to be able to design machines that handle them reliably despite the fact that they might vary in size, shape, color, consistency, one cooking time in another or one temperature in another. All of these things add up to variability that would confound most robots, but yet they're able to build automated systems that handle them correctly. And one of the problems with, at least with prepared food, cutting them. Lewin starts off with a very apt description of the problem in the kitchen level, at the home level, where you can kind of just feel when a knife is cutting something correctly, courtesy of, the wetware between your ears and the feedback, the force feedback you're getting from actually, having your hand on a knife. That doesn't exist in the automated factory food sort of realm. So you've got to figure out a way to do that. And one of the ways that manufacturers have found to make reliable cuts in soft or sticky foods is by attaching their knife blades to ultrasonic transducers. And that has the effect of kind of just, melting through the cakes. He's got some video in this article of ultrasonic knives going through food objects. And it's kind of amazing that the knife basically comes out with nothing on it. It looks as clean as it did when it started the cut. They still need to be sharp, but they're also particularly shaped, I guess, to kind of act in concert with the transducers that are attached to them to conduct the sound waves in the appropriate way. One of the disappointments in this article that I found was there's really no explanation of what it is about the ultrasonics that makes them more capable of cutting sticky things like cakes and cheeses and things like that. I don't know if it's ever been explored experimentally. I'm sure it has. There's, food science is a huge topic, and I'm sure somewhere there's an explanation for how ultrasound, how vibrating a blade at ultrasonic frequencies eases its progression through a food substance. I would love to see that explanation someplace, but I think for practical purposes, it really doesn't matter. You're just moving the knife blade very fast, and that's doing the sort of the equivalent of sawing, the sawing action that you would do, but just at a really, really high speed and a really, really short distance. You're replicating that sort of motion without getting a tearing and crumbing and sticking and all of those things that are going to be a problem for the manufacturer. This also reminded me of a project that this old Tony took on for a long time ago, and I wrote it up as a fail of the week because he didn't get very far. He wanted to make an ultrasonic knife, and didn't get very far. He basically took an X-Acto blade and put it on an ultrasonic transducer, and a whole bunch of problems with it. Didn't work out too well. However, ultrasonic knives for non-food purposes are also a thing. So something that's out there commercially and are pretty well known.
Your mentioning water jet cake cutters reminded me of the most insane food prep machine I've ever seen. I will throw the links in the show notes for you. It has the weirdest motion I've ever seen. It's got a big, giant rotating gear that you put the cake on, and then this gets spun around using the teeth that are on the outside of the gear. And then the whole thing goes back and forth. I don't even know what this bot is called. It gets rotated by 2 sets of timing belts on either side. And then when they move together, they can move it back and forth. And when they move opposite each other, they can turn it around. But it's one absolutely gigantic gear doing the motion. And I've always wanted to make one of these machines as some kind of an art project or something, because I think it's just the craziest mechanism. But here's a video of one cutting up cakes for you. I don't know if this thing is it water jet? I guess it is doing water jet. That's just so weird.
Yeah, it is. Yeah.
I guess it's just such a tiny jet that it doesn't waterlog the cake. But in my mind, this seems like such a horrible idea.
Got to be something that it's not compatible with, but.
Croissant. You get
Yeah, but who cuts a croissant?
How the hell would you cut a croissant? That's a good question, actually. Okay, so we need somebody to make one of these, replicate one of these machines, and build a croissant cutting machine for us. Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you see anything cool, let us know. Send an email to tips@hackaday.com. And for all the links of everything we've discussed today, head on over to hackaday.com/podcast. And until next week,
keep on hacking.
Ha! I'm now ready. Hooray.
Not too bad.
Something's afoot. Electrons moving too fast. Which one am I thinking? Oh, yeah, here. It's kind of like fast, cheap. What is it? Fast, cheap.
Fast, cheaper. No. What's the other one?
What's that triangle? Yeah, right?
Can't believe we couldn't remember that.
Oh?
What? What's that? All right, then. My quick pick. Not quick pick. Oh, my God. All right. And a pleasure.
All right. I think we have overstayed our welcome. I mean, done everything we need to do for this particular podcast.
Acting.